Morning, guys. Let's wait until 9:05 and then we will start our class today. Morning, guys. Let's start the class. So let's have a recap on what we have talked about in the last 2 weeks. So in the last 2 weeks, we introduced array. We introduced a single dimension array and two-dimension array. So for an array, what is an array for? Array is like a sequence of memory space in your memory that which can hold a lot, like a list of elements, which can store a lot of variables, a list of variables. This is what an array for. So to declare and to initialize an array, the syntax is like the your data type first. The type for this case is integer, and then your array name, and then your array length, and then a pair of curly braces, and then all the elements you wish to initialize with. Now you define an array. And then how you access an array? You access it like this: the array name, and then a bracket, and then your index. So remember that the index starts from 0. And how do you look through an array? Let's say you are given a requirement to print out all the elements inside an array. How can you do so? So we can make use of a loop. For example, an for loop. So using this for loop, you see we have one control like let's say it's control variable is called I to look through the array. You see, we are using the same I for accessing the array. We're using the same I as the index number. So this is how we look through an array and to print it out. And then also we talk about character array. So character type array is very similar to other kind of array like integer array, but then the difference is in when we initialize the array. For example, if you are initializing the character array, you see, you initialize it with like double quote and then your string inside. So the initialization is a bit different. But other than that, character array and the other kind of arrays are mostly the same. And then last week we talked about two-dimension array and multi-dimension array, which means like 3 dimensions array or 4 dimensions array. You can have as many dimensions as you want. For 2 dimensions array, how we going to initialize it? The syntax is like this. Your array data type, and then your array name, and then for the length of the first dimension and then the length of the second dimension. So usually for first dimension, we call it row. For second dimension, we call it column. So when we initialize it, let's say this is the first dimension, these 3 are the first dimension, 3 element, right? So we call this row, first row, second row, third row. And then for a second column, the second dimension, usually we call it a column. So this is the first column. 1, 6, 11 is on the first column. 2, 7, 12 is on the second column, third column, fourth column, and fifth column. And then remember that when you're going to access the data, the index starts from 0. So this applied for both row and column. So for this one, 1 is on array 0, 0, row 0, column 0. And then how you gonna look through this array? Let's say I ask you to print out all the elements inside this array. So how are you going to print it out? It's basically the same as a single dimension array, just that we need to have a nested for loop. So a sample of the nested for loop, let's take a look. So this is a sample of a nested for loop. So inside your for loop, you can have another for loop. And then you can print out something based on this I and J. Let's look at an example to print out two-dimensional array. Yeah, this is the example to print out two-dimensional array. So we have an array called array. This is actually quite a, okay. Yep. So we have an array called array, and then let's say this array has 3 row and 5 column. So for a loop, you can ask it to print out 3 times. For a second column, you want it to print out 5 times from 0 to 5. This is actually from 0 to 4. And then we can print out the array using index I and index j. Now you can print out all the elements inside your array. So these are all about array. Today, we're gonna talk about something new. Today, we're going to talk about pointers and reference. So pointers and reference is something unique to C++. So not all the other programming languages have this pointers thing. This is something unique in C and C++. So what is pointer for? So for this chapter, you don't have to, it's not, for this chapter, you don't have to like be an expert in pointer or reference or something like that. You just have to understand it. This chapter is like a brief introduction for you all to understand what is a pointer and what is reference, what's the concept behind them. And so what is a pointer? Pointer is something unique in C++. It's a very good tools. So what actually is it? Actually, just a memory, the address of your memory space, right? Pointers store the address of your memory space. And then it's a variable. So pointers is a variable. So why would we need a variable that store the address of our memory space? So we can use this pointer to manage our memory. For example, we want to allocate some new memory space, or we want to delete this memory space, disallocate this memory space, or release this memory space. Pointers can do this for us. So we can control the memory space through a pointer. This is what pointer for. And what is a memory address? So previously, when we talk about variable, we're saying that we store the variable somewhere, right? Store it somewhere in our computer. Where is it exactly? It can be, it's probably, most probably is in our memory. And then, so that means each variable has a memory space allocated to it, right? And then, so for pointer is the similar concept. Pointer is storing this memory address. And how can we get a memory address? For example, if we have a variable called A, how can we get the memory address of A? Can use a special symbol called ampersand. So this ampersand return the memory address of A. Let's look at an example. First, we need to declare a pointer type, right? So a pointer has a data type as well. That means for the location, for the memory address that the pointer is pointing to, what is what does this address actually storing? What is the data type for that type of data? So if that address is storing an integer type, this have to be an integer pointer. So we can write this type as integer. And then a very important thing is to use this symbol. This symbol is an asterisk. So this symbol state that this variable is of pointer type. And then later, your pointer name. And then how can you initialize your pointer? We can give it an address. We can initialize it with an address. So this syntax means we're going to store an address into our pointer. So equal means we're assigning the data on the right side to the variable on the left side. And so what we are doing, so when we are initializing an address, we store the address to in the pointer. What we are doing is that, let's say we have a variable A. Variable A is storing in our memory, right? And then it has of course, it will have a memory space address. It has a memory address. So we can assign this memory address to a pointer so that now the pointer always refer to this memory address. And now this pointer can manage this memory address. So we know that a pointer is pointing to a memory address, and actually this memory address stores a value. For example, this memory address stores an integer value. How can we access? We actually can access the value inside this memory address. How can we do so? So for example, when you print out something, usually we just write name, right? But if name is a pointer, we can add a star and asterisk in front. This means you are going to take the value out. You're going to read the value. So this prints out the value in the memory address. What if we want to reassigning the value in the memory address? We can do is similar to the above one. Now we can assign a new value to our pointer. But then it's because we said pointer is an address, right? This value is not an address. So you need to assign it to the value, the memory address of this pointer. So we are reassigning the value of this pointer. Now the memory address that name is pointing to will have your new value. So star means we're going to access the value. We're going to retrieve the value storing inside this memory address. Okay. So let's have a small recap. Like if we have a pointer called name, if you changing this name or we storing something into this name, what we are storing? We are actually storing an address, a memory address. If you are retrieving the value of name, what we got? We got a memory address because remember a pointer is storing a memory address. How about an asterisk name? This means we are managing the value inside the memory address. If name is storing a memory address, let's say the memory address is called 1234. So star name means inside 1234 we are storing a value, let's say it's an integer 1. Star name will return 1. Star name allow us to manage the value storing in this memory space. Let's take a look at an example. So we have an integer a and we initialize it as 10. And then we have an integer p. We're declaring an integer a pointer of integer type. And this pointer is called p. Okay, how we know this is a pointer? Because there is an asterisk here. So that means p is a pointer. And now we want to assign the address of a to pointer p. How can we do so? Remember just now we talked about how we get the address of a variable using a special symbol called ampersand. So if you write ampersand b in front of your variable, then you actually got the address of it. So now NA is the memory address of A. And then we're going to assign it to P. So now pointer P is pointing to the address of A. Now we want to reassign the value storing in in the memory space, in the memory address. Let's say we want to reassign it as X, right? So we are writing the X into asterisk P. What is asterisk P? Asterisk P means the value in the memory space, right? So we are actually reassigning the value inside this memory space. So if we print out A and P and ampersand A, what would we observe? you observe that A change into X as well. Why? Because P is pointing to the variable to the address of A. And if we change the value that is storing inside the address, it has the same effect. It affects A as well because A is storing in the same address. So actually, by using P, we can manipulate the data inside A. That's what we mean by P can be used, a pointer can be used to manage the memory. It can act like a proxy. So we manipulate P, but indirectly we manipulate other variables as well. And we can try it by ourselves inside a platform. So we define integer A, and then we define a pointer called P, and then we initialize P as we assign the memory address of A to P, and then we assign the value in the address to X. And then let's print out A and P, and also the memory address of A. Also, let's print out the value at P, the value at the memory address of P. So they are all the same. A is X. The value at this pointer, the value at the memory address is X as well. And then the address storing in P is this address, and then the address of A is this address. So basically, P is pointing to address of A. And then now we can manipulate A through P. And you see there are two steps here. We declare P, and then later we initialize P. This can be merged into one step to become like this. So we declare P and initialize P in one line. This is also allowed. There's some questions over here, a quiz. So which one is incorrect? We define A, and then we define a pointer P, and then we initialize P, and then we assign this memory space. Which one is incorrect? A is a pointer. This one is definitely incorrect. A is not a pointer. A is a normal variable. P is a variable. P is a variable. This is correct. P is a pointer variable. So this is correct. Because remember, pointer is also a kind of variable. P storing a value. The value that P is storing is a memory address. This is correct. Pointer is storing a memory address. All right. If we look at our demonstration again, when I print out P, what is being printed out is a memory address, right? Through A, we can manage the value storing in P. Not really. The concept is through pointer, we can manage the value in A. So this is incorrect. through pointer P, we can store and retrieve the variable storing at the particular address. This is correct. This is what pointer is for. Pointer allow us to manipulate the data storing inside the memory address. So 5 is correct. At which line error will be thrown? A equal 10, B equal, and A. At second line, error will be displayed, right? It's because yeah, at second line, error will be thrown because this is an address. We are trying to store an address to the integer type, and this is not allowed. We can actually try it by ourselves. Here A equal 10. And then B equal and A. Wait, let's play it. Error is being thrown here. B was a invalid conversion from integer star to integer. So that means this actually and A is a address type. You cannot simply assign an address type to an integer type. This is not allowed. Integer star means an address pointing to an address that is storing integer type. Because A is an integer type. So address of it is an address that is storing an integer data. So for the above question, what is the reason for the error? A was not declared in this scope, not correct. B was not declared in this scope, not correct. Conflicting declaration integer star B, not correct. Invalid conversion from integer star to integer. Yeah, this one. So in our demonstration is displaying invalid conversion from integer star to integer. That means we are trying to store an address inside integer. This is not allowed. Also, let's have a now we touch a bit about function. I think we haven't introduced function before, but let's take a look at an example. Let's say we have an integer main, a function called integer called main. Main actually is a function. So usually when we write our program, actually we must have a main. Main is the entry point for our program, right? So this is a function. Also, other than that, we can write other function as well. You can write other function. Let's say there's a show function, right? And let's say we have a show function now. This show function is to increase x and then display x. Okay. And inside our main function, we have an x with a value of 5. And then we pass this x into our another function. And then in this another function, x increased by 1. So now x should be 6. And 6 should be printed out. And then after finishing executing this show function, it return back to this line, print out x. So now, what do you think this x would be? Would it be 6 or would it be 5? Right? So the answer is 6 and 5. So here it prints out 6. And you expect x to be 6, right? But then here it prints out 5. Why is that so? Because we are passing by value. The concept for the way we are passing right now is called passing by value. So when we pass by value, actually C++, it make a copy of this x and pass it inside this function. So even though x is increased in this function, it's a copy of this x. It doesn't affect the previous x at all. It doesn't affect it. So even if we manipulate the x over here, it has no effect on the x in the main function. So this is the characteristics of passing by value. It doesn't affect the data in your caller function. So this is called a caller. It doesn't affect the data from a caller side. So as you can see, maybe this is not quite doing what we want. We want x to be actually increased by 1. How can we do so? We can make use of pointer. So we can pass by pointer. For example, we can define the show to accept a pointer type. So this pointer type point to the same address as the x over here. And if we manipulate the data over here, because it's a pointer, it points to the same memory address. The x over here should be affected as well, should be updated as well. So this is what we are trying to achieve for this example. Thus, let's say we can create a function called pass by pointer. So you can name this function anything as you like. And then this function is accepting some kind of parameter. So in our case, we want to pass in a. We have inside our main function, we have an integer a. And then we want to manipulate its data inside a function. And then after that, we want to print out a and observe that either the data of a has been updated. So now how can we pass by pointer? If this variable is accepting a pointer, how can we pass in a pointer? So remember, pointer is actually storing an address, right? Storing an address. So we can pass in the address of a. How can we do so? We can make use of the special symbol called n%. So we pass in NA, then an address is being assigned to P, to pointer P. And now if we manipulate the data in P, if we manipulate the data storing in the memory address pointed by P, let's say manipulate by data to 10, A will be affected, the value of A will be updated as well, because basically A and star P is the same thing. They are on the same address. So now A is being updated, A is changed. So if we print out A now, it will be 10. Let's try this by ourselves. See, 10 is being printed out. And we can try a previous one as well. See, 6 and 5 is being printed out. So let's look at the example again. So how can we solve the issue if we want the changes here to reflect here as well, right? We can accepting a pointer x, or to make it clearer, we name it as p. And then we update the value storing inside this address. to increase by 1. Then we can print out P. So here when we print out X, this should be 6 as well. This P would be 6, this X would be 6. And here when we pass in an X, remember to pass in its address. Yeah, so both are 6. And there's another example. After we initialize A as 5, now we are assigning the address of A to a pointer called B. And then we are passing this pointer into this function that is accepting a pointer. And then we are manipulating the value storing inside this pointer. So now after we run through these functions and then we're going to print out A, what do you think A would be? What would A be? A actually still will be 10 because now both B, A, and P are pointing to the same memory address. So if we change the value here, it affects all 3 variables, right? So if we print out A now, A will still be 10. We can try it by ourselves. Yep. A will be 10. And then how about array? Can we point the address, can we point to the memory address of an array? The answer is yes. And it's actually not that different from the normal way of how we work with pointer. So because array and the pointer have very close relationship, because inside our compiler, you turn this array into the form of pointer. So it's quite easy to make our pointer, let's say we initialize a pointer and point it to the address of an array. It's quite easy. Let's say we have an array A with 10 elements and we initialize it as an empty array. Now, if you want to assign the address of A, we want to assign the address of this array to a pointer C. It's actually very simple. Just assign A to this pointer C. It doesn't have to write the %. Why? Because in C++, the compiler converts the array into the form of pointer. So the pointer will point to the first element of this array. Let's try this by ourselves. See, it prints out the first. This is actually it prints out a memory address, but this is actually the first element of A. So if we initialize A as 1, 2, 3, and then we print out C and the value at C. What will the value at C be? It should be 1 because it's pointing to a first element, right? It should be 1. And then what if we use the normal way? The normal way is to write the ampersand, right? Ampersand and then which index you want. I mean this is the variable. A0 is the variable which is the first element of the array, and then you add an ampersand. These two are basically the same, these two methods. So either you can assign with your array name directly, or you you can assign it, you can get the address through the variable inside your array, and then through this ampersand. Let's say let's say we want to access the B, let's say B is the second element or the third element. Let's say B would be the third element, pointing to the third element of this array A. Now we can print, if we print out B, you see it's printing out the address of this variable, and then it prints out the value of this variable, which is 3. So there's an example here. Someone enters a string with a length of 10, and then we are given a task to reverse this string. So let's say we have a string with length of 10. So we can define a character array which is named S with a length of 10. And then here we are assigning the array to a pointer P. And then we are going to read in this array. After we read in this array, because a task is to print out the character array in reverse, prints out the string in reverse. So what we can do is that we start from the last index and loop until a first index, until index 0. And then we print out the value that is storing in the array. How can we do so? If we make use of pointer plus 0 means the value is at index 0. Pointer plus 1 means that is the address for first value. Pointer plus 2 means that is the address for a second value, right? And then star means to get the star means to get the value storing at this address. So by making use of a pointer, you can print out a string in reverse. If we try it by ourselves, let's say our string is hello world. It prints out in reverse, right? So the concept here is T plus 0 is pointing to the address of index 0 in this array. P plus 1 is pointing to index 1 of this array. And then if we apply a star in front of this inside of this, if you apply an asterisk in front of this address, we're actually retrieving the value that is storing at this address, right? That's why we achieve these are the task given to print out the string in reverse. But for this task, actually, we don't have to use an array. This is just to demonstrate that array can retrieve the value as well. But for this task, it's simple enough that we can just print out SI. Yeah, this task is simple enough. We actually don't have to make use of this pointer. So the pointer is just for demonstration purpose that we can retrieve the data storing in an array through pointer as well. There's another example. If someone enter a number n, and then we need to print out n results, the mean of n data, and you make use of array and function. Oh, that's a long program. So here we have a main function. Inside a main function, we read in n, and then we read in n, and then we define a pointers called scores. So these pointers is initialized as an array. This pointers is initialized as an array, and then later on we read in n scores, and then we want to call a function to process these n scores. This is to calculate the average, and then after that we want to delete the scores. Why? Because just now new integer n means we are allocating new memory space for this array. After we make use of it, after it is not being needed anymore, we need to delete it to release this memory space so that other program or other code can use this memory space, so that we won't run out of memory space, right? So after we make a new, we need to delete this as well. Actually, this is something advanced. We have never talked about. We have never introduced this new and delete thing. So it's okay if you not quite get it. This is a new topic. We haven't had time to introduce it yet. Basically, this is allocating a new space, a new memory space in a new space in the memory. And this one is to release this memory space. And then what is happening inside this get average function? This get average function is accepting an array of scores, like n scores, and then accepting a length. Length is actually n. We pass in n to this length. And here we define a total, and then we look through all the scores, we add up all the scores into a total, and then the total divided by length is the definition of mean, right? So basically, we are getting the average of this. Let's say if n is 5, we are getting the average of these 5 scores. So after we got the average, we are returning the average, right? And the average should be printed out. And so basically, I think this sample is demonstrating that by using this pointer, we can easily pass. By using a pointer, we can easily pass our array into another function, and it can process data of the array inside this another function, right? So there's a small demonstration of the usage of pointer, and that's basically what you need to know about pointer. You don't have to be an expert in it. You don't have to be very super familiar with it. You just need to know the concept, because pointer is something quite advanced. You won't touch it that often actually. So to recap, pointer is something, a variable. Pointer is a variable that is storing our memory address. And how can we declare a pointer? So the format for it is the type. What is this type means? This type means the value storing at the memory address. If your memory address storing a float or double or an integer or character, this type has to be the same as the data type inside memory address. And then we can have an asterisk to declare that this is a pointer. And then the pointer name. And when we initialize this pointer, initialize it with an address. Also, how can we get the address from a normal variable? Let's say your variable is an integer type, right? How can you get its address? You add an ampersand in front of your variable name, like NA, then you get the address of it. And then what is a function? So main also is a function. Main is the main function, but also we can create our own function. For example, so we can create a function called name. And then before we write this name, this is your function name. Before that, this is the return type. If you are going to if your function is going to return a value, so you have to declare the return type here as well. Let's say this value is an integer. So this type has to be integer. And then after that, there can be a bracket here or a parenthesis here. So this inside this parenthesis, you can declare a few parameters. So the caller have to pass in some parameters. This is a sample. The caller have to pass, sorry, this is a sample. We have two parameters here. The caller have to pass in the parameter scores and to pass in the parameter length. And then, as you can see, for our main function, usually we are actually returning an integer. So we declare this as an integer. This actually cannot be changed. So the convention is that always in our main function, it should be written as integer main something, and then return 0, right? And then there's something special over here, you see. We actually write the get average twice. Why is that so? That is because, you see, because in C++, the code is executed from top down, right? So the compiler is actually processing a code from top to down. So inside, if we have not written this line and we write this main first, when the compiler is processing this code, it saws get average, but then it doesn't have any info about get average. So it doesn't know that how to process this. So because get average is written down here, right? So we need to declare the get average above to let the compiler know that, oh, we actually have a get average function and it is returning a double type and is accepting two parameters with integer type, so that the compiler knows that how to verify whether we are calling this function correctly. So that's why we need to declare the return type and the parameters type of this get average function at the top. Alternatively, we can move this get average function before we define integer main. So both works. If you move this before the integer main, we don't have to declare this on top. Let's look at it. Okay, actually we can try it out by ourselves. So if we have integer main, so let's try run the original one first. So this works, right? If we remove this line and run it, it throws error saying that get average was not declared in this scope. So our compiler can understand what does get average means, what is the return type, what is the parameters type. But then if we move this up, move this before before we write the integer main. So this works as well. So this is the concept behind declaring our function. And basically that's all for today's lecture. Today we have talked about pointer and address. Right? We talk about how we define a pointer, how we initialize a pointer, and how we manipulate the data, how we manipulate the data inside a memory address through a pointer. And then next week we'll talk about something unique also. This is called reference. Okay. Next week we'll talk about reference, and if we have extra time, maybe we'll talk about something about the string library of C++. So stay tuned for next week. Let's take a short break. Later at 10:05, we will go through some of the exercises in our platform. Hey guys, let's continue with our exercise session. So this exercise, the first question is talking about, to print out the address of our variable. So now we have variable, we are given variable A, B, C, and we're going to print them out. How can we print them out? You can apply the ampersand in front of your variable. So NA, NB, and NC. We print it, it prints out the address at A, address at B, and address at C. And then the next question. So next question is to get a what does this means? Or to make use of the asterisk to get the data storing inside this memory address. So let's say we have variable A and variable B, and then we define a pointer. This pointer points to the address of A. And then we need to print out the value at the address, and then we print out the value at these addresses. So the value at A is 123. The value at A is 123. The value at the address of B is 321. And next question. We discussed about this already just now in the lecture, but let's go through it again. So which statement is incorrect? We define A as 10, and then we define a pointer P, and then we assign the address of A to P, and then we reassign the variable in this address to X. So which is incorrect? A is a pointer. This is incorrect because A is not a pointer. A is a normal variable. P is a variable. This is correct because a pointer is also a variable. The value storing in P is a memory address. This is correct. Remember, pointer is storing a memory address. So through A, we can manage the value storing in P. No, this is false. So we cannot control value storing in P. So P is storing a memory address. So I mean this is incorrect. How about through P, through a value, through asterisk P, we can store or retrieve the variable storing at that memory location. This is correct. This is the use case of pointer. So through a pointer, we can manipulate the data storing in this memory address. At which line arrow will be thrown? So at the second line. We tried it already just now. So why arrow will be thrown? Because we cannot assign a memory address to a normal integer variable. It has to be assigned to a pointer variable. So why would the error be thrown? It's because invalid conversion from integers asterisk to integer. So integer asterisk is basically means a pointer type. So pointing to an address that is storing an integer value. This is about reference. We haven't introduced it yet. We will introduce reference in next week. So let's skip this. Reference, pass by value, pass by reference. There are some more questions about pointer. So given the following program, which one is incorrect? A is 5, and then we're assigning the address of A to P, and then we're assigning P to B. I think this, sorry, we're assigning the value of this address to P to B, which statement is incorrect. N% is a memory address. This is correct. Remember, N% is for us to access the address of our variable. So this is correct. P is a pointer. Yes, correct. Because there's an asterisk in front of P, right? So P is a pointer. P is memory address. This is actually correct because a pointer is storing a memory address. So let's assume that it's saying that P is storing a memory address. So this is correct. B is a memory address. This is not correct because B is a normal integer type, a normal variable type. So it stores the value. It doesn't store a memory address. You see, as you can see, we are assigning the value storing at P to B. So B is storing a value, a normal data value, not storing a memory address. So the last one is incorrect. So for this question, we have a variable charge with integer type, and then we define a floating point variable P, or it's a pointer. So this pointer P should be pointing to a memory address that is storing a float type. So we are assigning an address to it. So this address is storing an integer type. So this is not correct, right? Because pointer P is supposed to point to an address of float type, right? So what is the possible error? Variable naming issue? No, this is incorrect. There is no variable naming issue over here. Charge and P are perfectly fine. The first line of the program should be integer star charge equal 10. Not really. That means the first line should be a pointer. No, this doesn't help. Does this help? Yeah, this doesn't help. The second line of the float P the second line should be float P equal to and charge. This is not correct as well. This is not the reason that the errors occurs. So the error occurs because the last one, a float type pointer can only manage a float type memory space. So this is the reason. So which statement is not allowed, is invalid? Integer A equal to 10. And then we have float B equal to 1.234. And then we define floats, a pointer float with a pointer pointing to an address with float type. There is no problem. This is correct. Integer, a pointer type. We assigning a pointer type my variable with integer A. This is not correct. It's supposed to be an A, the address of A, right? So this is not correct. Integer star P equal to NB. That means we are storing the address of a variable float, the address of a float variable to an integer pointer. This is not correct. This should be float pointer. How about this? We store the address of a float variable to a float variable. This is not correct. This is invalid because we cannot store an address to a normal variable, to a normal data type float. This has to be have an asterisk so that BP is a pointer as well to make it work. So this is incorrect. How about the last one? We are storing the address of A to a pointer AA, an integer pointer AA. This is correct because A has type integer as well. Then we are assigning an address to a pointer. So this is correct. So what should be filled up here to make our program print out number, NUM? So here we have a function called print. This print is accepting a parameter called P, and P is an integer pointer. And we are going to print out P, the value in this integer pointer. So what should be passed into this array? Remember, P is storing and pointer is storing an address, right? So here we have to pass in an address. How can we pass in an address? Can make use of a special symbol, ampersand. So ampersand num. This is the answer. So the following program will print out the first element inside our array. So we have an array with 5 elements, 1, 2, 3, 4, 5, and we're assigning this the address of the array to a pointer P, and then we print out the first element in P. If you want to manipulate to update the array into 1, 2, 7, 4, 5, what should we do? Then we have to manipulate 3 and change it into 7, right? So how can we do so? One method is to make use of a pointer. If pointer P, initially P is pointing to the first element in the array. We demonstrated it just now actually. So pointer is pointing to a first element. So for third element, it should pointer address plus 2 will be pointed to the third element. And then you have to add a star in front to tell that we want so that we can access the value storing at this memory address. And we are assigning 7 to this memory address. Right? This one is correct. And then a simpler one would be directly manipulate this array, right? Array and then index 2 equal to 7. We are assigning 7 to array index 2. So remember, index starts from 0. So index 0, index 1, index 2. How about this? P plus equal to, and then assign 7 to P. This is actually valid. So we increase the address by 2. We increase the address by 2, and then we assign 7 to our to the value storing in this address, right? This is actually a valid. How about this? Array equal 1, 2, 7, 4, 5. This is not allowed. We cannot do this. That the syntax just doesn't support this, right? Yeah. Think basically that's all about pointer to the so yeah, so we have go through all the exercises on pointer. And So just to recap, today we have introduced pointers and then on how to declare pointers, how to define, how to initialize a pointer, how to retrieve the value stored in this pointer, how to manipulate the data stored in this pointer. Also, we actually touch a little bit on function. So the return type of the function, the parameters inside a function, and then pass by copy, pass by pointer, and the declaration of the function. So this is what we have introduced this week. Actually, this is quite a lot. And then next week, we'll introduce reference. And if you have extra time, we'll introduce some helpful string library functions as well. And so stay tuned. Thank you for listening. See you guys next week.